Hello all, welcome to Unacademy. Today we will going to see our next lecture on statistics. In this statistics we will see moments, skewness and kurtosis. Okay. Now see, in first lecture yesterday we have seen in the statistics how to find out the whatever it is, normal distribution, probability distribution, everything we have seen. And now today we are going to see how to find out the sorry, how to find out the skewness, moments and kurtosis. Okay, so in this, before going to start this, let me introduce myself Dhanashree Palasdeokar. I completed my MSc in mathematics from Mumbai University and having 13 plus years of teaching experience, and I taught to many students of engineering maths. Before going to start this, let me introduce how to install the Unacademy's learning app. So in short while we will see, this is the step 1. You have to search Unacademy's learning app on your Play Store app, then install the Unacademy's learning app. After that, step 3, you have to manage your goal, that मतलब आप लोग कौन से कोर्स के लिए पढ़ना चाहते हैं वो आपको यहाँ पे मैनेज करना है आपका गोल. जैसे कि हम लोग अभी गेट एंड ईएसई के लिए पढ़ रहे हैं. Okay, then take the subscription, whatever you want, either it is free subscription, plus subscription, special classes, that is up to you. And after that, getting the subscription, the most important thing I will going to tell you that if you want a 10% discount on your subscription fee, use my promo code DSP so that you will get 10% discount on your fees, and you can pay the fees by using any one of this method. Okay. Before going to start this, we will start our actual topic, that is moments. Okay, what you mean by moment? Okay, many times actually it is a term which is many times used in a physics. Okay, the term moment has been taken from the physics. In physics, the moment of a system of a point masses is calculated with the formula identical to that above, and this formula is used in the finding the center of the mass of a point. It means summation of fi, we can calculate n is equal to sum of fi. Okay, and in statistics the values are no longer masses, but as we will see, the moments in statistics still measure something relative to the center of values. Okay, in physics moment is also used for to find out the center of masses. Here we will see in the mathematics or in statistics, the same moments are used for the to calculate the relative center of the values. Okay, now moments are very useful in statistics because they tell you much about your data, whether the data is deviated or whatever it is. You can find out the way data is deviated, how much it is deviated, whether that curve is flatness of the curve or peakness of the curve. Everything with the help of moments you can find out. Now there are four commonly used moments in the statistics. The first is mean, variance, skewness and kurtosis. Yesterday we have seen how to calculate the mean and variance and standard deviation, everything. Okay. Now, here is we will see how to find out the skewness and kurtosis. Now, the mean gives you measure of the center of data, that we have seen yesterday. What you mean by mean and what are the methods to calculate the mean. Okay, mean, mode, median, everything we have seen in detail in the previous lecture. You can go through it. The video is already available on YouTube. Now see the first formula, the moment about mean. Actually, there are three types of moments: moment about origin, moment about mean, and moment about any point. Okay, here we will see moment about mean. The rth moment of a variable x about the mean x bar of a distribution is denoted by mu r and is defined as mu r is equal to 1 by n summation of xi minus x bar bracket raised to r, विदाउट फ्रीक्वेंसी, मतलब यहाँ पे फ्रीक्वेंसी दी नहीं है, then data is given in this format. Okay, without frequency, it means discrete data is given. Okay, so whenever discrete data is given, we can find out the moment about mean. Because mean क्यों बोल रहे moment about mean, because here we are using mean x bar. Yesterday we have seen what you mean by mean. Mean is the, see here, x bar, mean is denoted by x bar. Mean of the values of xi is x bar, denoted by x bar. So mu r is equal to 1 upon n summation of xi minus x bar bracket raised to r. This is the moment about mean without frequency. Now mu r. What do you mean by mu r? Mu r is equal to 1 upon n summation of fi into bracket xi minus x bar bracket raised to r with frequency where n is equal to sum of fi. Okay, with frequency with n is equal to sum of fi. Here fi is given. Now we know that how to calculate the mean whenever the frequency is given. Yesterday we have seen by using that formula, mean x bar is equal to summation of fi into xi upon n. Okay, here we will use that to calculate the moment about mean. Okay, this is the formula we will use. Now the moment about any value at a. Okay, कौन से भी point के लिए value दी है, a is any point. Okay, the earth moment of the variable x about any point a of a distribution is denoted by mu r dash. Okay, the earth moment of a variable x about any point a of a distribution is denoted by mu r dash and is defined as mu r dash is equal to 1 upon n summation of fi into xi minus a bracket raised to r, which is equal to 1 upon n summation of fi into di raised to r if the frequency is given. Okay, if the frequency is given, then see here about any point a. In the previous, about moment about any point, about moment about mean. Here is we are applying mean. Okay, here we will use any point a. Okay, so mu r dash is equal to 1 upon n summation of fi into xi minus a bracket raised to r, which is equal to 1 upon n into summation of fi into di raised to r if the frequency is given. So mu r dash is equal to 1 upon n into summation of xi minus a bracket raised to r if the frequency is not given. Okay, if the frequency is not given, then we can find out the moment about at any point a by using this formula. 0 is equal to 1 upon n, so that is mu 0 is equal to 1. Okay, after calculating that values, you will get mu 0 is equal to 1. So moment at 1, first moment about value a is mu 1 is equal to 0 and mu 2 is equal to sigma square. See, you can use the mu 2. See here, mu 2 is equal to 1 upon n summation of fi into xi minus x bar bracket raised to 2 is nothing but the sigma, because sigma is equal to what? Standard deviation. Yesterday we have seen standard deviation is nothing but 1 upon n summation of fi into xi minus x bar bracket square, right? So if we take the squares on both sides, then square root will get cancelled out. So you will get sigma square is equal to this. This is nothing but the mu 2, which is moment about mean, second moment about mean. Okay, that is your mu 2. Mu 2 is equal to sigma square. Okay, we can directly calculate sigma square if the mu 2 is given. Okay, mu 2 is equal to sigma square, that is your variance. Now standard deviation sigma you can calculate by using root of mu 2. Okay, sometimes the values are given mu 1, mu 0, mu 2, mu 3, then calculate the standard deviation. So it's a very simple way to you can calculate the standard deviation with the moments about any value a is given. Okay, so sigma is equal to square root of mu 2. Now from equation 2, we can see that from equation 2, if you put r is equal to 0, 1, 2, 3 and so on, then you will get mu 1 dash is equal to mu 0 dash is equal to 1, mu 1 dash is equal to x bar minus a, and which implies mu x bar is equal to mu 1 dash plus a. It means directly whenever the mu 1 dash values of mu 1 dash are given, you can calculate the mean x bar as mu 1 dash plus a. No. Relation between the moments about mean mu r in the terms of moments about at any point mu r dash. Okay, since mu r is equal to 1 upon n summation of fi into xi minus x bar bracket raised to r, so di is equal to xi minus a, so xi is equal to a plus di. Okay, so you will get xi is equal to a plus di. So mu r is equal to, now what is the relation between moment about mean and moment about any point a? So mu r is equal to this. So mu r, we know that mu r is equal to 1 upon n from equation 1. Mu r is equal to 1 upon n summation of fi into xi minus x bar bracket raised to r, where di is equal to, di is the deviation of xi from a, right? So di is equal to, yesterday we have seen how to calculate di. So di is equal to xi minus a. So here xi is equal to a plus di. Okay, so you will get directly xi is equal to a plus di. Now mu r is equal to, now just put xi, value of xi here, that is a plus di. So a plus di minus x bar bracket raised to r, which implies 1 upon n summation of fi into, now see a plus di, I am taking di outside, so that you will get x bar minus a. Okay, so that you will get x bar minus a. So x bar minus a bracket raised to r, which implies 1 upon n into summation of fi into di minus mu1 dash. This is nothing but di minus mu1 dash. I am here writing minus sign. Okay, here di minus x bar minus a bracket raised to r. So here x bar minus a, we already find out x bar minus a is equal to nothing but mu1 dash, right? So we will write here x bar minus a, instead of x bar minus a, here we put mu1 dash. Okay, so that you will get, see, here is mu r and here is mu1 dash. So this is the relationship between moments about a mean mu r in terms of moments about any point mu r dash. Okay, now putting r is equal to 1, 2, 3, 4, we get, we put r is equal to 1. So you will get mu1 is equal to 0. R is equal to 2. You will get mu2 dash minus mu1 dash bracket square. Mu3 is equal to mu3 dash minus 3 mu2 dash into mu1 dash plus 2 into mu1 dash bracket cube. Mu4 is equal to mu4 dash minus 4 into mu3 dash into mu1 dash plus 6 into mu2 dash into mu1 dash bracket square minus 3 into mu1 dash bracket raised to 4. So mu r is equal to mu r dash. In general, you will get mu r dash. Mu r is equal to mu r dash minus rc1 into mu dash r minus 1 mu1 dash plus rc2 mu dash r minus 2 mu1 dash bracket square minus rc3 and so on, plus and so on, minus 1 raised to r into mu1 dash bracket raised to r. So you can calculate, generally we will calculate these four. Mu1 is equal to 0, mu2 is equal to mu2 dash minus mu1 dash. So you have to remember these four formulas. Moment about in any point, relationship between, when the moments about at any point A is given, then how to calculate the moment about at mean. Okay, so these four formulas are very important. Without this, you can't find out the moments and skewness or kurtosis. Okay, so you have to remember these four formulae, and if you can't remember this, you can use only this one. Just put the values of r is equal to 0, 1, 2, 3 and so on. Okay, so moving forward, we will see skewness. Okay, what you mean by skewness? Now, for symmetrical distribution, the frequencies are symmetrically distributed about the mean. Okay, whatever mean is given to you, this distribution is symmetrically distributed about the mean. In such distribution, the mean, mode and median are coincides. Okay, somewhere the mean, mode and median are coincides. Now the skewness means, what you mean by skewness? Skewness means lack of symmetry. But this lack of symmetry will be considered regarding with the normal distribution. Okay, so whatever your normal distribution is there, see, this is your normal distribution. Now generally the normal distribution is regarded with, this is your central value. Okay, so it is equally distributed from the left and from the right. Okay, if this equal distribution is not there, then we will consider it as either it is positively skewed or negatively skewed. Okay, this lack of symmetry is nothing but the skewness. Now see, positively skewed. What you mean by positively skewed? If the curve has a longer tail towards the right side, see, this tail is longer towards the right hand side, then we said that this distribution is, now this is the tail of the distribution. Okay, if the curve has a longer tail towards the right side, then it is positively skewed. For positive skewness, mode is less than median, less than mean. See, I already told you that skewness is symmetrically distributed about the mean, mode and median. Okay, so whenever the distribution is right hand side or the tail is positively skewed, when we say that the tail is positively skewed or the distribution is positively skewed, when the it has positive side, longer tail towards the right hand side of the distribution. Okay, now see here, positively skewed. Positively skewed, it means mean mode is less than median, less than mean. So mean is the at the peak, right? Suppose this is your mean. Okay, after that it is, here is median. Suppose here is median, and after that here is mode. So mean is mean, median, and mode. Okay, mode is less than median and median is less than mean. Okay, this is your positively skewed. Okay, this distribution is positively skewed. Why? Because most of the data is lie between this. Okay, most of the data lie between this. We can take this as most of the data lie between these two lines. Okay, so therefore there is a longer tail on the right hand side of the normal distribution, right hand side of the central value. Okay, we will take one example how we can see that positively skewed, the data is positively skewed. Okay, now see, if suppose the data is given of heights of a student, suppose heights of a students are given. Okay, this is your central value. Okay, I mind rough out this. This is positively skewed. Now see the data of the students. Some data of the students, height of a students are given. Suppose here is 1.5 is the central value. Height is given in meter. Okay, suppose 1.5, 1.3, 1.1, 0.9. Okay, and here is 1.7, 1.9 and 2.1. Okay, suppose the heights of a students are distributed like this. Heights of students are distributed like this. Okay, so if you observe, the heights of a student vary between 1.1 to 1.5, which is left hand side of the central value. Okay, so maximum value is vary between this side. So maximum value vary between this side. So this is positively skewed. Okay, so therefore this data is positively skewed because we are taking 1.5 is the central value. Okay, so therefore this is a positively skewed distribution. Now see, negatively skewed. If the curve has a longer tail towards the left, see, this tail is towards the left, longer tail towards the left. It means most of the data lies right hand side of this central value. Okay, so this is the, see, whatever the skewness is here, it is compared regarding with the normal distribution, because it is assumed that it is equally distributed. Okay, equally distributed, normal distribution is equally distributed to the left side and right side. Okay, left hand side and right hand side, it is equally distributed. So whatever skewness, it means what? Lack of symmetry. So whatever lack of symmetry is there, it is comparing with this normal distribution, right? They negatively skewed. If the curve has a longer tail towards the left side, then the negatively skewed. Then the distribution is negatively skewed. For negative skewness, mode is greater than median is greater than mean. It means here you will get mode. Mode is greater than median and median is greater than mean. So this is your negatively skewed. Okay. So this data is negatively skewed. Negatively skewed. I hope you understood this concept, positively skewed and negatively skewed. Okay, so that if the data is totally lies right hand side of the central value. Now this is your central value. As I told you, the central value is considered with the normal distribution. We assume that the normal distribution, see, there is a zero skew. The skew, normal distribution skewed zero. Why? Because it is equally distributed. Now see, this is the lack of symmetry comparing with the normal distribution. This is our lack of symmetry. Okay, here, see here, here is a lack of symmetry comparing with the normal distribution. Yeah, now see, negatively skewed. Now see, if we take the data of marks scored of the some students, data of marks scored of the students in an easy test. Okay, see, suppose marks are computed from year 20, suppose 30, 40, 50. Here is 60, 70, 80, 90, 100. Okay, the central value is 60. So if you observe, most of the students scored the marks between 60 to 90, right? Most of the students scored the marks, maximum marks scored by that students in an easy test is between 60 to 80. Okay, so therefore the lack of symmetry over here, on the there is a longer tail on the left hand side of the central value, therefore it is negatively skewed. Okay, so therefore it is a negatively skewed. There is a tail, longer tail. Okay, so negatively skewed. Okay, so this is the best example of the negatively skewed. Now this is a normal distribution. If the anything is given, suppose height or anything, if I take the example, same example, if the income distribution is given, okay, if the income height of a students are given and income distribution is also given, then you can check the income distribution if it is equally distributed on both the sides, then that distribution is called as normal distribution. Okay. Now, see, coefficient of skewness, and coefficient of skewness is denoted by the letter beta 1 and is defined as mu 3 square upon mu 2 cube. Okay, mu 3 square upon mu 2 cube. So mu 3 square upon mu 2 cube is mu 2 and mu 1, mu 2, mu 3, mu 4. We know that how to calculate mu 1, mu 2, mu 3, mu 4 by using this. So beta 1 is the coefficient of skewness denoted by beta 1 and is defined as beta 1 is equal to mu 3 square upon mu 2 cube. Okay, if beta 1 is equal to 0, then the distribution is symmetrical. As I told you, the normal distribution is in the normal distribution, the value of beta 1 is 0 because it is distributed symmetrically. Okay. Now, what are the uses of skewness? As I told you, the moments are generally used in a skewness. And what is use of skewness? It describes the data in a descriptive statistics. As I told you some examples here, heights of a students or income distribution of a people or any marks code of the students in an examination. All the data directly you can here describes by using the skewness how it is distributed. Okay, it tells where your data is deviated. As I told you, see how the data is deviated. Here data is deviated, right? If you see the actual your normal distribution curve look like this. So this much is the lack of symmetry. Okay. So that data, how much data is deviated is given by the skewness. Okay. Now skewness can be used to obtain approximate probabilities and quantiles of the distribution, such as value of risk in finance. It means whether we have to invest in the whether we have to do the finance or whatever it is, that totally depending upon the value of skewness. Via the Cornish-Fisher expansion, many models assume normal distribution, that is data are symmetric about the mean. The normal distribution has the skewness 0, okay, because it is equally distributed, as I told you. Now, the next point is kurtosis. What you mean by kurtosis? Kurtosis is again a type of moments. Okay, kurtosis is a statistical measure that defines how heavily the tails of a distribution differ from the tails of a normal distribution. Okay, it means as I told you, the normal distribution is like this. Suppose this is your normal distribution. Assume that this is a normal distribution. Suppose this is a normal distribution. It is equally distributed. Now kurtosis tell you how the tails of a distribution differ from the tails of a normal distribution. Okay, sometimes the tails are look like this or like this. Okay, so kurtosis tells how it is differ, or it means kurtosis tells the thickness or flatness of the curves. Okay. In short, the kurtosis signifies the thickness of a distribution, thickness or flatness of a distribution. Okay. Now see, kurtosis is a statistic from the normal distribution. Okay. What skewness tells us? Skewness is tells us lack of symmetry. Okay. Skewness is tells us lack of symmetry, and the kurtosis is tells us flatness or thickness of a symmetry. Now, along with the skewness, kurtosis is an important descriptive statistic of data distribution. However, the two concepts must not be confused with each other. Skewness essentially measures the symmetry of distribution, while kurtosis determines the heaviness of a distribution tails. Okay, as I told you, skewness determines lack of symmetry and kurtosis determines peakness or flatness of a distribution curve. Okay. I hope you all are clear what you mean by kurtosis and skewness. Now here, beta 1 denotes the coefficient of skewness and here beta 2 denotes the coefficient of kurtosis. So beta 2 is equal to mu 4 upon mu 2 square. If beta 1 is equal to 0, then the distribution is symmetrical. Okay. If the beta 1 is 0, then the distribution is symmetrical. Now, types of kurtosis. So what do you mean by types of kurtosis? So there are many types of a kurtosis. There are many types of kurtosis. First is mesokurtic. Okay, first type is mesokurtic. What do you mean by mesokurtic? See, data that follows a mesokurtic distribution shows an excess kurtosis of 0 or close to 0. This means that if the data follows a normal distribution, then it follows the mesokurtic distribution. Okay, mesokurtic distribution, if see our normal distribution look like this, and see, I have seen on here the mesocultic, it means the normal distribution look like in a mesocultic is the same as the normal distribution. See, that follows the normal distribution. This is the normal distribution. This one is the normal distribution, the mesocultic distribution. Okay, this is our normal distribution. Assume that this is a normal distribution. Okay. Now it follows the mesocultic distribution. It means the what it indicates that if it is mesocultic, then definitely it indicates that the beta 1 value of beta 1 and beta 2. So what will be the value of beta 2? So beta 2 is the 3. Okay. So the value of beta 2 is 3. Okay. Now here second one. Second type of kurtosis is leptokurtic. Okay, what do you mean by leptokurtic? Leptokurtic indicates a positive excess kurtosis. The leptokurtic distribution shows heavily tails on the either side, indicating large outliers. Okay, in finance, a leptokurtic distribution shows that investment returns may be prone to extreme values on either side. Therefore, an investment whose returns follow a leptokurtic distribution is considered to be risky. Okay, so as I told you, what is the use of the kurtosis here? To identify the riskness. Okay, whether we have to do finance or anything, that will be identified by using this kurtosis process. Okay, now this is leptokurtic. Now suppose this is your normal distribution, then here is a peak. Here the leptokurtic distribution gives the peakness. Okay, so here is peakness. Now as compared to the normal distribution, this is the leptokurtic kurtosis. Okay, so it gives a risk. Okay, now platykurtic. A platykurtic distribution shows a negative excess kurtosis. Okay. The kurtosis reveals a distribution with flat tails. Okay. The kurtosis reveals a distribution with flat tails. The flat tails indicates the small outliers in a distribution. In the finance extent, the platykurtic distribution of the investment returns is desirable for investors because there is a small probability that investment would experience extreme returns. Okay. So by using this kurtosis technique, many investors can invest their funds. Okay, so this is your flatness of the curves. It means if you compare with all the three, If beta 2 is less than 3, then distribution is called as platykurtic. If beta 2 is equal to 3, then the distribution is called as mesokurtic. If beta 2 is greater than 3, then the distribution is called as leptokurtic or more peaked. Okay. Now, this is leptokurtic. I'm showing all this in a one diagram only. This is leptokurtic, this is mesokurtic, and this is platykurtic. Okay, all the kurtosis distribution is here. So leptokurtic, mesokurtic, platykurtic. As I told you, beta 2 is equal to 3 because this is our beta 2 is equal to 3 is the standard value for the kurtosis. Okay, if it is excess value, when we say that the excess value of the kurtosis, so generally we denote the excess value of kurtosis is by gamma 2. Gamma 2 is equal to beta 2 minus 3 is the excess value of kurtosis or excess of the kurtosis. Okay. Now, if beta 2 is greater than 3, then the distribution is called as leptokurtic or more. Everything is covered in this. We will see our first example, that is the first four moments about the working mean. See, 30.5 of a distribution are 0.0375, 0.4546, 0.0609 and 0.05074. Calculate the moments about the mean. Also calculate the coefficient of skewness and kurtosis. Okay. So coefficient of skewness and kurtosis, that we have to find out beta 1 and beta 2. Okay. So for that, what is given? Mean is given about point. So A is equal to 30.5. Okay. And the distributions are given. The first four moments, it means mu1 dash is equal to 0.0375. Mu2 dash is equal to 0.4546. Mu3 dash is equal to 0.0609. Mu4 dash is equal to 0.05074. Okay. Now these 4 points are given. 4 moments about any point A is given about mean. Okay. Now by the relation between mu r and mu r dash, we will write down by the relationship between mu r, by relation between mu r and mu r dash, by relation between mu r and mu r dash, we get mu1 is equal to 0, mu2 is equal to mu2 dash minus, I'm writing here all these things one by one. Okay, so that it is easy to calculate. Say mu1 is equal to 0. So what is mu2? Mu2 is equal to mu2 dash minus mu1 dash, mu2 dash minus mu1 dash bracket square. Okay. Now, so what is mu2 dash? Value of mu2 dash is 0.4546. Here we can write 0.4546 minus mu1 dash. Value of mu1 dash is 0.0375. 0.0375 bracket square. So just calculate this. You will get value of mu2 is equal to 0.4531. I already calculated it. I am just writing over here 0.4531. You can cross verify with the help of calculator. Okay. Now mu3 is equal to, now we know the formula for mu3, that is mu3 dash minus 3 mu2 dash into mu1 dash plus 2 mu1 dash bracket cube. Okay, just put the values of mu3 dash, mu2 dash, mu1 dash. So mu3 dash, value of mu3 dash is 0.0609, 0.0609 minus 3 into value of mu2 dash 0.4546 into mu2 dash, mu1 dash is 0.0375, 0.0375 plus 2 into mu1 dash cube. So mu1 dash cube 0.0375 bracket cube. So after calculating all these values, you will get value of mu3 is nothing but 0.0098. 0.0098 is the value of mu3. Yes, exactly similar way we can calculate value of mu4. Value of mu4 is equal to, I am writing the formula over here, mu4 dash 4 dash minus 4 mu1 dash mu3 dash plus 6 into mu1 dash square into mu2 dash minus 3 into mu1 dash raised to 4, which is equal to, now put the values, mu4 dash is 0.05074 minus 4 into mu1 dash is 0.0375 into mu3 dash 0.0609 plus 6 into mu1 dash 0.0375 into mu2 dash 0.4546 minus 3 into mu1 dash 0.0375 bracket raised to 4 is equal to. So after calculating all these things, you will get 0.0454. Okay, I'm writing all the values as it is. And after calculation, you will get this. You can cross verify. Okay, now after doing this, we have to find out the coefficient of skewness, that is denoted by beta 1, and beta 1 is equal to mu3 square upon mu2 cube, right, which is equal to, now what is the value of mu3 here? 0.0098, 0.0098 bracket square upon mu3 square, mu2 cube 0.4531 bracket cube, which is equal to 0.001. As you see, this beta 2 is, lack of symmetry is very small. Beta 1 is equal to 0.001. So what is our beta 2? So shall I rub this on calculating our beta 2? Yeah. You can calculate beta 2 here. Beta 2 is equal to, I am directly writing here value 0.001. Value of beta 1 is here 0.001. You can do the calculation by putting the values. Now beta 2 is equal to, here you will get mu4 upon mu2 square. Mu4 upon mu2 square. Okay. So what is the value of mu4? 0.0454 upon mu2 is 0.4531 bracket square, 0.4531 bracket square. So beta 2 is equal to 0.2211. Beta 2 is equal to 0.2211. Since beta 2 is less than 3, beta 2 is less than 3, we can say that this distribution is platypurtic. As I already told you here, if beta 2 value of beta 2 is less than 3, then the distribution is platypurtic. It means your distribution is look like this. Okay, there is a flatness for the, if you draw the curve for this moment, then you will get the flatness of the curve. Okay, now let's see example. This example, find the coefficient of skewness and kurtosis of the distribution from the following data. Okay, now data is given in a different way. See, summation of FIDI is equal to 50. Summation of FIDI square is equal to 1970. Summation of FIDI cube is equal to 2948. FIDI raised to 4 is equal to 86754. See, here we will use the formula, see, for the mu r dash, because moments are not given. Moments about any point are not given. Okay, so we know that the moments about any point A, the formula for that, mu r dash is equal to what? 1 upon n summation of Fi di raised to r. Okay, so to get first moment, so we will use this here. You put r is equal to 1 to 3. So put r is equal to 1. So you will get mu1 dash. Here you will get mu1 dash is equal to 1 upon n. All the values are given. 1 is nothing but the sum of the frequencies, that is given 1 upon, that is 1 upon, sorry, that is 100. Sum of the frequencies is 100. Okay. So 1 upon 100 into summation of FIDI raised to r. FIDI raised to 1. It means summation of FIDI, which is equal to 1 upon 100 into 50, is equal to 1 by 2, that is 0.5. mu1 dash is equal to 0.5. Okay, so similarly we can calculate mu2 dash is equal to 1 upon n into summation of FIDI square. Okay, so 1 upon 100 into summation of FIDI square is given 1970. Okay, so it will gives you 19.70. Similarly, we can calculate mu3 dash, which is equal to 1 upon n summation of FIDI cube, which is equal to 1 upon 100 into summation of FIDI cube is given 2948. 2948. 2948. So it will gives you 29.48. Mu4 dash is equal to 1 upon n summation of FIDI raised to 4 is equal to 1 by 100 into mu4 by mu4 here given FIDI raised to 4 86752. Okay, 86752. This is totally calculation oriented topic. So just the calculations, you will get your moments. So, mu3 dash, mu4 dash. Okay, now everything we already calculated here. 7 8 not 86, that is 867.50, that is 29.48, 19.70. Okay, now moments about mean. Now the next point is, this is moments about at any point A. Now moments about mean, we required it, no? Moments about mean. Hmm? So mu1 is equal to 0. Calculate mu2 is equal to mu2 dash minus mu1 dash square. That you have to remember. Mu2 dash minus mu1 dash square. Okay, so mu2 dash 19.70 minus 0.5 square. 19.70 minus 0.5 square, which is equal to, so your final answer will be mu2 is equal to 19.45. You can cross verify it. 19.45. Okay, mu3 is equal to mu3 dash minus 3 mu2 dash mu1 dash plus 2 into mu1 dash cube 29.48 minus 3 into mu2 dash 19.7 into 0.5 plus 2 into 0.5 bracket cube. So you will get mu3 is equal to 0.18. Mu3 is equal to 0.18. Mu4 is equal to mu4 dash minus, we can write minus 4 into mu1 dash, 4 into mu1 dash 4 into mu1 dash into mu2 mu3 dash plus 6 mu1 dash brackets cube, square into mu2 dash minus 3 into mu1 dash raised to 4. Okay. Now just put the formula, just put the values in that formula. So you will get in the formula here only. Values here only mu4 dash. Value of mu4 dash is 867.52 minus 4 into mu1 dash is 0.5, mu3 dash is 29.48 plus 6 into mu1 dash square. mu1 dash is 0.5 square, mu2 dash is 19.7 minus 3 into mu1 dash is 0.5 raised to 4. Okay, 0.5 raised to 4 in that, which is equal to, I am writing here the final value, mu4 is equal to 837.9225. Okay, this is your value about mu. Now we can calculate the coefficient of skewness and kurtosis. That is beta 1 is equal to mu3 square upon mu2 cube. Okay, which is equal to 0.18 bracket square upon mu2 is 19.45 bracket cube, which is equal to 0.0000. Okay, no, it means there is no lack of symmetry, it is normal distribution. Okay, beta 2 is equal to coefficient of kurtosis, that is beta 2 is equal to mu4 upon mu2 square. Value of mu4 is 837.9225 upon mu2 square. Mu2 is 19.45 square. So which is equal to 2.2149. 0.2149. Okay. So the value of beta 2 is less than 3. If the value of beta 2 is less than 3, then we say that the distribution is platychotic. Okay. Now see the next example, that calculate the first 4 moments of the following distribution about the mean and hence find beta 1 and beta 2. Okay. Calculate the first 4 moments of the following distribution about the mean and hence find beta 1 and beta 2. Now the raw data is given. It means first 4 moments दिए नहीं है. Okay, find the following distribution for the about the mean and hence find beta 1 and beta 2. Only raw data is given. It means no mu1 dash, mu2 dash, mu3 dash, mu4 dash are not given. So first of all, we have to calculate the mu1 dash, mu2 dash, mu3 dash, mu4 dash. Okay, now see, for that we required fi xi or if only these things are given, so we have to calculate the mu1 dash, mu2 dash, mu3 dash. We can calculate by using summation of 1 upon n. We know that mu r dash is equal to summation of 1 upon n into summation of fi di raised to 4. So for that we have to prepare one table. Okay. So see, here we can write the values of xi, then values of fi. For the formula we required di. So di is equal to xi minus a. We have to choose a. A is the middle value from the given xi, from which all the values of the xi deviated from that value. Okay, di. So fi into di, then fi into di square, fi into di cube, fi into di raised to 4. That we have to calculate. Okay, the values are given 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 up to 8. The values are given 1, 8, 1, 8, 28, 56, then 70, 56, 70, 56, then 28, 8, 8, 8, 1. Okay. All the values are given. Here di is equal to xi minus a. We can choose a from any one of these. Now how many values are given? 1, 2, 3, 4, 5, 6, 7, 8, 9. So fifth value is the middle value. Okay. So 4 is the middle value. So xi minus 4. We can take value of a is 4. Okay. So every data is deviated from 4. So 0 minus 4, minus 4. 1 minus 4, minus 3, 2 minus 4, minus 2, 3 minus 4, minus 1, 4 minus 4, 0, 1, 2, 3, 4. Fi into di. So minus 4. We can calculate here. Minus 24, minus 56, minus 56, 0, 56, 56, 24. And 4. Now if you observe, we can get the summation of fi into di plus 4 minus 4 plus 24 minus 24 plus 56 minus 56 minus 56 minus 56. So easily we will get the sum of fi into di is equal to 0. So our calculation efforts are reduced now. So sum of fi into di is equal to 0. So if fi into di square, so we can calculate fi into di square. First take the square of di. So minus 4 square is 16. 16 into 1, so 16. Minus 3 square, 9. 9 into 8, 72. So like that we have to calculate minus 2 square, 4. 28 fours are 112. Right? So you will get then fi di square, di minus 1 square into 56, 56, 0 square into 70, 0, 1 square into 56, 56, 4 square, so 112, 3 square, 9, 22, square 16. The summation of fi di square will get summation of phi di square is equal to 512. Phi di cube. Exactly when. Now this you can do with the help of calculator. So the square you will get minus 64 minus 216 minus 224. You can cross verify it. Every value you can cross verify. Plus 56 to 24, then 216, then 64. We will get summation of Fi di cube is equal to 0. 256, 648, 448, 56, 0, 56, 448, 648, 256, summation of Fi di raised to 4 is equal to 2816. Summation of Fi is equal to 256. Okay. Now every value we got here. Now we will find out moments about at any point. So mu r dash is equal to 1 upon n summation of Fi into di raised to r. Now put r is equal to 1, mu 1 dash 1 upon n summation of Fi di raised to 1. It means Fi di is equal to 1 upon 256. No? Just now we have calculated summation of Fi is 256. So 1 upon 256 into summation of Fi di is 0. So you will get mu1 dash is 0. Mu2 dash is equal to 1 upon n summation of Fi di raised to 2. 1 upon 256 into summation of Fi di square. So summation of Fi di square is 512, which is equal to 2. Right? Now mu3 dash 1 upon n summation of Fi di cube is equal to 1 upon 256 into mu3 dash is summation of Fi di cube is 0. So again mu3 dash is 0. Now your calculation efforts are reducing. If you are getting 0 many times, then calculation efforts are reducing. Once you are getting 0, you should be happy. Fi di cube, which is equal to 1 upon 256 into what is Fi di raised to 4? 2816. So 2816. That is 2816, which is equal to 2816, 256 upon 2816 is equal to 11. Okay. So all the values here we are getting. Now just find out mu1, mu2, mu3, mu4. Okay. Now this example is lengthy but easy. Once you know the formulas, then the example is easy. Okay. Now mu1 is equal to 0, mu2 is equal to mu2 dash minus 3 into mu2 dash into mu1 dash plus 2 into mu1 dash bracket cube is equal to 0. Why? See, most of the values are 0. See, yeah. Mu1 dash is 0 and mu3 dash is 0. Here mu1 dash is 0, mu3 dash is 0. Okay. So mu2 is equal to, sorry, mu2 dash minus mu1 dash square. I'm sorry. This value is mu2 is equal to mu2 dash minus mu1 dash square. So mu2 dash is 2 minus mu1 dash, means 2 minus 0 equal to 2. Now mu3 is equal to mu3 dash minus 3 into mu1 mu2 dash into mu1 dash plus 2 into mu1 dash cube. Okay, here mu3 dash is 0, mu1 dash is 0, and mu1 dash is 0. So ultimately your value will become 0. Okay. Now mu4 is equal to mu4 dash minus 4 into mu3 dash into mu1 dash plus 6 into mu2 dash into mu1 dash square. Okay. So which is equal to, you will get, after putting all the values, you will get value of mu4 is 11. Now we can calculate coefficient of kurtosis and coefficient of skewness. Coefficient of skewness, beta 1 is equal to mu3 square upon mu2 cube is equal to mu3 is 0, mu2 is 2 cube, that is again 0. Beta 2 is equal to mu4 upon mu2 square, 411 upon mu2, 2 raised to 2, 4, 11 by 4, so 2.75. So beta 2 is less than 3. Again the distribution is Platy-Kurti. Okay, therefore distribution is Platy-Kurti. Okay, I hope you clearly understood this example. If the raw data is given, okay, then how to calculate the coefficient of skewness and kurtosis. The next example, which is very interesting, now see, find the first 4 moments of the following distribution about the mean and hence find beta 1 and beta 2. And hence beta 1 and beta 2. Okay, अभी beta 1 and beta 2 दोनों find out करने हैं. मार्क्स दिए हुए डेटा जो है वो continuous distribution format में है ना. The data is given in a continuous distribution format. So यहाँ पे हमें क्या करना होगा, उसके लिए फिर से टेबल बनाना है. 1 सेकेंड देखते हैं. हमारा यहाँ पे टेबल बन जाएगा. हमें तो फॉर्मूला पता है, म्यू आर डैश इज इक्वल टू क्या है, हमारे पास कुछ भी नहीं है, 1 अपॉन n समेशन ऑफ एफ आई डी आई रेज टू आर, है ना. हमें ये सब निकालना है, उसके लिए एफ आई डी आई लगेगा. तो उसके लिए हम लोग जो भी वैल्यू दी हुई है उसका यूज करेंगे. 0 to 10 ये है क्लास, और ये है क्लास मार्क एक्स आई. हमें यहाँ पे लगेगा डी आई एक्स आई माइनस ए, देन एफ आई दिया हुआ है, देन एक्स आई एफ आई इंटू डी आई स्क्वायर and fi into di cube, fi into di raised to 4. Okay, तो क्लास दिया हुआ है 0 to 10, 10 to 20 कंटिन्यूस क्लास डिस्ट्रीब्यूशन है, 20 to 30, 30 to 40, 40 to 50, then 50 to 60. xi is given 5, 15, 25, 35, 45, 55. Okay, now di is equal to xi minus a. तो xi है ये, हमें a चूज करना है. 1 2 3 4 5 6, 6 में से है, so we can choose either 25 or 35. so I'm choosing 35 here. xi minus 35, उससे कोई फर्क नहीं पड़ता, सब कैलकुलेशन रिड्यूस, एफर्ट्स रिड्यूस करने के लिए हम लोग ये कर रहे हैं. So di is equal to xi minus a. So 5 minus 35 minus 30 minus 20 minus 10 0 10 20. Okay, now frequency is given 1 6 10 15 11 then 7. Now sum of the frequencies we require n. Summation of fi is equal to 50. You can cross verify. So it is 50 fi into di, our usual calculation. Fi into di, that is minus 30 minus 120 minus 100 0 110 140. Okay, we require summation of fi di. So summation of fi di, if you see the summation of fi into di is equal to again 0 140 110, that is you will get 250. 250 plus this minus 250 again 0. Summation of fi di is equal to 0. fi di square, अभी di का square करना है. Okay, so ये value बहुत बड़ी हो जाएगी. fi di square you will get 900, then 2400. I am directly writing here because already I calculated this. 0 1100 1100 2800. This is our fi di square. So summation of fi di square is equal to 8200. You can cross verify. Now fi di cube. So minus 27,000 for minus 48,000 minus 10,000 0 11,000 56,000. Okay, summation of fi di cube is equal to minus 18,000. fi di raised to 4 is equal to 81,000. But 81, it is 8,10,000. 4 zeros. 5 zeros. 0 1 1 1 2 4 1 1 2 0 0. So summation of fi di raised to 4 is equal to 41 zeros. 39. So total values are already calculated. Now we will just put this value in the given formula of mu r dash. Okay, so mu1 dash, what will be our mu1 dash? mu1 dash is equal to 1 upon n summation of fi di is equal to 1 upon 50, because summation of fi is 50. So 1 upon 50 into summation of fi di is 0, so 0. mu2 dash is equal to 1 upon n summation of fi di square is equal to 1 upon 50 into summation of fi di square 8200, which is equal to 164. mu3 dash is equal to 1 upon n summation of fi di cube is मैं यहाँ पे हर एक एग्जाम्पल लिख के दे रही हूँ. जो भी इंजीनियरिंग मैथमेटिक्स के लिए भी पढ़ रहे हैं स्टूडेंट, उनके लिए भी ये वीडियो बहुत इंपॉर्टेंट है. Okay, यहाँ पे आपका probability और statistics whole unit cover up हो जाएगा for the computer science and IT के student के लिए. 3 dash is equal to 1 upon n summation of FIDI cube upon 1 upon 50 into summation of FIDI cube is minus 0 minus 6, which is equal to minus 360. Now mu 4 dash is equal to 1 upon n summation of FIDI raised to 4 1 upon 50 into all. Now we got all the values mu 1 dash, mu 2 dash, mu 3 dash, mu 4 dash. Now we will calculate mu 1, mu 2, mu 3, mu 4. Okay, so shall I write the values directly here? Because you know how to calculate it. Mu 1 is equal to 0, mu 2 is equal to mu 2 dash minus mu 1 dash, mu 2 dash minus mu 1 dash square, which is equal, I'm writing only the value 164. You put the values. Mu 3 is equal to mu 3 dash minus 3 mu 2 dash plus 2 into mu 1 dash is equal to 1 dash cube चाहिए यहाँ पर. 1 dash cube is equal to, you will get minus 360. Mu 4 is equal to mu 4 dash minus 4 into mu 1 dash mu 3 dash plus 6 into mu 2 dash into mu 1 dash minus 3 into mu 1 dash raised to 4, which is equal to 62,000. Okay, so therefore beta 1 is equal to coefficient of skewness mu 3 square upon mu 2 cube is equal to, here, minus 360 square upon 164 is equal to 0.02938. Beta 2 is equal to mu 4 upon mu 2 square, which is equal to 6200 upon 164 bracket square is equal to 2.3051. Okay, this is the value of coefficient of skewness and coefficient of kurtosis. See how the calculations efforts we have to take here to calculate the beta 1 and beta 2. Okay, so 2.3051. So obviously it is less than 3. So again the distribution is plateaued. Okay, now the next example is, find 4 moments about the mean of the following. Also calculate beta 1 and beta 2. This example is similar to this one. This example number 5 is similar to example number 4. Here xi and fi is given. In this example also x and f is given. X and f is given. So the data is large. So that we will do in this way. Okay. Now again we require mu 1 dash, mu 2 dash, mu 3 dash, mu 4 dash. Same, I hope you know how to find out it. I'm just putting the values here. You can cross verify. See, if you, the students who are from the engineering stream, so anybody can see this topic or this lecture is very important for the GATE and ESE also, and also for the students who are appearing for the engineering. Okay, So for the second year, M3 is there. So you can see the topic probability and statistics for the computer science and IT branch. You will get the same topic. If you study this lecture, your whole topic of statistics regarding with moment, skewness and kurtosis will be done. So I try to cover up each and every point so that you are able to solve any example depending upon skewness kurtosis. Okay. I hope all of you are clear here. I know it's a process is lengthy, but there is no any other option without solving this. Okay. Phi is given 518, 518, 42, 27, 8. Di is equal to, I'm taking here middle value 1, 2, 3, 4. The third value is 67. So xi minus a 61 minus, so minus 6 minus 3. I'm writing now. You are very smart to do the calculation. You are very smart as compared to me also for the calculation. I have seen many students are liking statistics, okay, because there is only many students like calculations, okay, or some may be not. I don't know what about you, but summation of FIDI is equal to 45. Summation of FI is equal to 100. FIDI square. I'm writing everything because you know how to calculate. I'm not wasting the time. Without wasting the time, I'm writing the value directly. Now you know the process how to calculate this value. So 729, 1728, summation of FIDIQ is equal to 891, 6480, 1458, 0, 2187, 10368, summation of FIDI raised to 4 is equal to 20493. Okay. Now immediately I'm calculating mu1 dash. You can calculate this mu1 dash 1 upon n summation of FIDI raised to r, because those who are watching later they will also understand. So 1 upon n is equal to 100 into summation of FIDI raised to 1. This is the formula. I'm sorry. This is the formula for mu r dash. Now I am calculating mu1 dash equal to 1 upon 100 into summation of FIDI raised to 1, which is equal to 1 upon 100 into summation of FIDI is 45, so which is equal to 0.45. Mu2 dash is equal to 1 upon 100 into summation of FIDI square. 1 upon 100 into summation of FIDI square is 873, is equal to 8.73. You will get mu3 dash is equal to 1 upon 100 into summation of FIDI cube is equal to 1 by 100 into FIDI cube 891, which is equal to 8.91. Whole dash is equal to 1 by 100 into summation of FIDI raised to 4 is equal to 1 upon 100 into summation of FIDI raised to 4 is 20493 is equal to 204.93. Okay. So by using this, you can calculate mu1, and now I am writing the values directly here. Mu1 is equal to this, mu2 is equal to mu2 dash minus mu1 dash square, which is equal to 8.73 minus 0.45 bracket square, which is equal to 8.5275. Now mu3 is equal to mu3 dash minus 3 times mu2 dash into mu1 dash plus 2 times mu1 dash cube. Okay, so which is equal to 8.90, sorry, you get minus 2.69 minus 69325 is mu3. Mu4 is equal to 1 upon mu4 is equal to mu4 dash minus 4 times mu3 dash into mu1 dash plus 6 mu2 dash into mu1 dash square minus 3 mu1 dash raised to 4, which is equal to 199.4580. 199.4580 is the value of mu4. Okay, I think कुछ people bore होंगे, but there is no any other option without calculating these values that we want to calculate. So beta 1, now the last point is beta 1. Beta 1 is equal to mu3 square upon mu2 cube, so which is equal to minus 2.69325 bracket square upon mu2 cube is 8.5275 bracket cube, which is equal to 0.011698. 0.011698. Okay. Now beta 2 is equal to mu4 upon mu2 square, which is equal to 199.4580 upon 8.5275 bracket square, which is equal to 2.7429. Okay, now that's it. I think all of you are clear, each and every point whatever I covered from this topic. Okay, how to find, what you mean by skewness, what you mean by kurtosis, what you mean by coefficient of skewness. Okay, everything what you mean by moment, everything I covered up here. Okay, so I hope you understood each and every point. Okay, so moment and revising only in 1 minute. So what you mean by moment? Moment is a very useful in statistics because they tell you about your data, how it is, how the data is. What do you mean that? What we will say? The moments in a statistics, the mean, variance, skewness, and kurtosis. The mean gives you measure of center of the data. Okay, how the data is deviated from the center, that totally calculated by using moments. Okay, now whatever the data is, skewness, it means skewness signifies the lack of symmetries. Okay, skewness tells you how the data is having lack of symmetry. Okay, skewness is nothing but the lack of symmetry. Exactly similar way, kurtosis gives you the thickness or flatness of a given distribution. Okay, kurtosis gives you thickness or flatness of a skewness. Okay, if the thickness is more, then the kurtosis is leptokurtic. See, if the thickness is more, then the kurtosis is leptokurtic. If the thickness is little bit flat, then the kurtosis is platykurtic. If the thickness is equal to the normal distribution, then the kurtosis is mesokurtic. Okay, and generally the standard value for the kurtosis is measured for 3. Majority is 3, and whenever it is deviated from 3, if it is less than 3 or greater than 3, then the kurtosis is called as platykurtic or mesokurtic or leptokurtic. Okay, here we solved each and every type of example. If the directly moment about mean is given, then how to calculate the value of skewness and coefficient of skewness and coefficient of kurtosis. If the values are not given, then how to calculate that values moment about at any point A, how to calculate when the data is given like this. Okay, and if the data is given like this, then how to calculate the value of mu r dash. Then after that, using mu1 dash, mu2 dash, mu3 dash, we can calculate mu1, mu2, mu3, mu4. After that, we can calculate beta 1 and beta 2. Then after finding all the values, see if the data is given in a discrete format with the frequency distribution, then how to calculate beta 1 and beta 2 by using this formula. Now, whenever the data is given in a continuous distribution format, then how to calculate the beta 1 and beta 2. Here we solve the example. Now, this example is similar to the previous one, only where here the data is given in the large format. See, x is equal to 61, 64, 67, 70, 73. And frequency is 5, 18, 42, 27, 8. So, everything we are solved here. I cover up each and every point from the statistics, whatever is required for your GATE and ESE exam, as well as the students who are appeared for the engineering. They also having this lecture is this lecture is also important for those students who are appearing for the engineering maths. Okay, it is totally one unit, which is probability and statistics. I already cover up each and every point of the probability from the last two to three lectures. I already delivered 4 lectures on the probability, and this is our second lecture on statistics. Yesterday we have seen how to find out the mean, mode, and median from the statistics. Okay, and here we calculated the skewness and kurtosis. In next lecture we will see correlation and regression analysis. So keep watching. Thank you so much.